So in this particular section, we're going to look at what Danny talked about and what we talked about earlier in terms of hybrid clouds, but more from a perspective of how the platform influences the creation, the management, the decomposition of applications, etc. So this is the context that Steve showed you guys very early in terms of the demo. And if you look at it, there were really a couple of components that make it a hybrid environment. The first one is that there are certainly new workloads, new systems of engagement that are being built off premises, whether it's in a dedicated environment or in a public environment, and they traditionally tend to focus on engagement models with the client. You also have a set of capabilities that you need on-premise, and this is really what Bluemix Local or IBM Cloud Local is targeted at, which is how do you start integrating with your existing capabilities, whether it's mainframes with things like zConnect, with your existing business processes, your ESBs, your existing applications and the APIs. And for a lot of reasons, it's how do you build an edge system that lets you manage your data, manage the deployment of applications that need to work locally in terms of visibility of data, etc. So with this particular application model in mind, one of the things that we've been going through is trying to understand what is a cloud platform and what is the rendering of the cloud platform, both from a public perspective, a dedicated perspective, and a local perspective. Danny mentioned very explicitly that consistency across these environments, from a programming model perspective, from a management model perspective, is going to be very critical to provide you the flexibility of choosing the right deployment model to achieve the business outcomes. So in that context, if you look at a typical application space, you certainly have a set of existing applications. Depending on the industry, you have customer information, business processes, inventory data, etc. In many cases, we call it legacy, but to me, legacy is actually a business advantage. The amount of information that's in your back-end systems, the amount of processes that are encoded that are important to the running of a business are actually points of advantage. And if you look at almost any environment, those are the things that really bring value to client interactions, being able to marshal the data, be able to put in place effective business processes. So this is an important area. But where the industry is moving now is how do I take and unlock those processes and be able to compete in a much more engaging model? And that's where, to a large extent, a cloud platform comes in. My personal opinion, when we talk about IaaS, PaaS, SaaS, I think that decomposition is just a point of taxonomy. But when you look at the real implementation of systems, it's a service-oriented model. I have infrastructure services, I have platform services, I have APIs to SaaS services. How do I use those APIs to build a set of applications? How do I use a set of foundational services that helps me build scalable, internet scalable applications? And that's a very important element, because when you start looking at decomposition to microservices, having the core set of services, much like we had in the web world or in the J2EE world, becomes very critical to have those services. And we'll get into a little bit more detail on that. Having a set of business services that you can marshal, having a set of integration capabilities to bring in everything from mainframes to existing APIs to be able to deliver it through cloud native applications. And then obviously partner services, API catalogs, etc. So in this context, when we look at our cloud journey, we really focus on 5 key elements. First of all, what's a cloud platform? Again, as I said, it's infrastructure, services, platform services, APIs, etc. What are the portfolio of services that are available and what qualities of services we offer in that context? And services could be business services, they could be middleware services, they could be management services, they could be logging services, monitoring services, the entire spectrum of services that are available so that you can effectively build applications at a rate and pace that the industry demands. The third part, as we asserted, is secure integration between off-premises and on-premises, between on-premise cloud systems and back-end systems. So the whole area of integration is a key element in how we transform enterprises and their applications today progressively into the cloud world. One of the interesting factoids is if you look at the budget of a typical IT organization, let's say you're spending $1 billion in IT, the amount spent on new applications is actually a small amount compared to the overall spend. So when you start looking at things like return on investment and so on and so forth, it's not necessarily picking a tool or picking a platform for just the new applications, but how do you optimize existing applications as well? So the set of capabilities that a cloud platform provides to be able to automate, optimize existing applications, integrate existing applications is a critical part of an overall cloud platform. And finally, you can only move as fast as your development processes allow. Being able to create effective APIs, being able to expose those APIs, being able to support new models of development, being able to support DevOps and continuous delivery, the technologies and tools that enable you to do that are very critical. So if you look at the overall platform and our cloud directions that enable people to build applications, I think the spectrum and the entirety of the capabilities and how it's knit together is, I think, an important characteristic of how we build new application and what is it that supports your endeavors in this space. So the first part, and we'll go through it progressively, I mentioned earlier that existing applications and optimizing them is something that is a critical part of the cloud journey. I mean, there are basic models like lift and shift, but when people do a lift and shift, they just don't do a lift and shift. They look to rationalize their portfolio. They look at automating it and standardizing it. So the set of tools that enable you to create patterns of deployment become very important in terms of the velocity of development, the DevOps functions, as well as in standardizing and optimizing cost. There's a set of technology that supports that. As Danny mentioned, a lot of it is based on open technology. We look at OpenStack Heat and Hot as mechanisms to represent existing application landscape, and then the set of tools underneath to automate it and deploy it, not only on a single cloud, but across multiple clouds, whether it's AWS or Azure, but also on-premise. And the flexibility that you get from that is actually very critical, because you can make the decisions of how you represent your application, but choose the deployment to happen at particular other times on particular other clouds. So this set of technology is actually fairly critical. But this predominantly focuses on existing workloads. What we are also seeing, and I think Steve alluded to this earlier on in his presentation, is that we are going from monolithic applications to a much more decomposed set of microservices for a variety of reasons. Flexibility, the ability to support the rate of change for business agility, breaking down individual components and their data, let you expose very granular APIs but assemble them in interesting ways. So this journey is something that we are seeing in a variety of ways. No doubt it's for building new applications, but we are seeing several enterprises take some aspects of their application and refactor them as microservices. When you look at a microservices ecosystem, you also land up with needing a core set of services. Whether we're looking at a service registry or service proxies, API gateways, new ways of testing applications, things like A/B testing, new architectural patterns like circuit breakers, encryption when you start looking at hybrid models, not only encryption, but also data transformation. I might not want to move all data. I might want to tokenize data when I move it off-premise. So the set of capabilities that you need to support a microservices architecture is as important as the decoupling of the application logic itself. And to get into a little bit more details of how we deliver these services and what we do in this space, I'll give it to Jason.
Thanks, Bala. So let's go down a level and talk about what this kind of modern application architecture is that Bala alluded to. I mean, I think a lot of us have heard the term microservices, or maybe we've heard the term cloud native, but have we really kind of consumed what that means from an architecture standpoint into our applications, and what are the services that a cloud platform needs to provide to support that? So let's do definitions first, because microservices and cloud native go together, but they really represent different characteristics of what a modern application structure looks like. The microservices idea is really about how do you organize a development team to be able to deliver quickly? How do you structure the application itself as this set of loosely coupled, mostly independent, fixed function or single function services that you can compose together? And by doing that decomposition, what you're really doing is you're making a trade-off. You're trading off more agile, more rapid delivery, because you can make changes in an area of an application without impacting the other parts of the application. One of the key ideas of microservices is each service has an independent lifecycle. There's a team, a relatively small team, who owns that service, who's responsible for making changes and updates to that service, that's exposing an API or a contract with everybody else that says how that service is consumed, and that can make changes and updates to that service independently of changing anything else in the application, that can scale that component of the application independent of scaling everything else. So you've kind of freed up the team to work in these smaller units and therefore go faster, have less scope they have to deal with, have less tests they have to deal with. But you've traded off operational complexity. Right? You have, frankly, a much more complex application that now has many moving parts. We've worked with clients, for example, who have taken monolithic applications, decomposed them into microservices. They started with an original application that was maybe, let's say, 10 to 20 instances running in a clustered environment to handle load. They broke that down into 300 microservices. Each of those 300 microservices is its own cluster of instances with their own load balancers and rules between them. So you go from having 10 to 20 things running to having 1,000 things running, right? Much more complex operational model, right? But much more rapid development. So microservices is about how do we optimize the application to support a rapid development team. Cloud native is about understanding the environment that that application is going to run in. Modern cloud platforms have certain assumptions built into them about how things run. They're focused, for example, predominantly on a scale-out architecture, where you add capacity to the application by adding instances. Cloud-native environments tend to lean towards more stateless style application components. You don't maintain servers that you deploy. You dispose of them and replace them with new ones. If something fails, you get rid of it. You get a new one. When you deploy a new version of the application, you don't upgrade in place. You deploy a new version of the application, you test that it works, you transition work to the new version, and you shut down and delete the old one. So there's a certain set of environment assumptions that are represented by this idea of building an application to be cloud native, meaning architecting that application to fit into the standardized environment that the cloud represents. And as you look at new applications, you have to kind of consume these two ideas and think about how they should be represented in the application workloads you're building. And don't worry about all the words on this chart. Worry about the picture a little bit. If you think about a microservices application, so in this example, we have a simplistic application that's made up of 5 microservices. Some of those microservices face the outside world. Right? They accept requests coming into this application. Some are internal only. They're used as components within the application. To run an application like that, you have a set of problems that you have to solve. How do I route traffic amongst the components of this application? How do these services find each other? Right? How do they know where their peers are and who's up right now and who's down? Right? How do I build these components and deploy them into production in a non-disruptive way? Right? How do I run this efficiently? How do I run 300 services, 3 copies each, without consuming massive amount of physical resource that I might if I did something like run them all on VMs, where I have an operating system footprint for every instance of the service? So what you need is a cloud platform or a foundation that provides a set of capabilities to help support applications of this style. Right? You need service discovery to help applications find each other. You need intelligent service proxies on the edge and in between the components of the application to help traffic be routed in a way that's aware of versions, aware of availability of the components of the application. You need a platform to run those services on. A container-based platform, most likely, either direct containers like Docker or containers like Cloud Foundry provides, which are just different ways or different trade-offs on how you control the software that's within that container. You need an ability to actually manage and control the deployment. Right? How do you roll out a new version of an app? How do you do a red-black deployment where you bring up a new version, make sure it's okay before you shut down the other one? Or how do you do what's called canary testing? Like, I want to bring up a new version of that service and send like 5% of the traffic over there and make sure everything looks good before I roll that service out to everybody. So there's a set of foundational services that wrap around these modern applications that provide the components that you need to support the deployment, operation, and management of these types of applications in a cloud environment. And so one of the things that we've been doing in IBM Cloud, and you see this exposed through Bluemix, is building out this collection of capabilities. Steve flashed up a variant of this chart this morning. What we've been thinking about is how do we decompose all of those horizontal problems into services themselves. What most people are doing today as they build microservices apps is they're actually either building themselves all of the framework capabilities you need to manage the microservices app, or they are deploying and managing some framework that they're acquiring from somebody else. But this is cloud. We should be able to solve these problems through services and APIs. And so this foundation set of capabilities is doing just that. It's giving you a common way to do service proxies or to do service discovery, a common way to do logging and monitoring, a runtime like containers to run those applications on. All of the storage and networking capabilities that you need, the deployment control capabilities like Active Deploy that can manage the rollout of new applications. Those things are all provided as services that you can link to through APIs and leverage as part of the development process for deploying and running these new applications. And that really forms the underpinnings for any kind of cloud-native microservices app. So I could redraw that picture that I showed just a second ago and substitute in these services in green that are provided by the cloud platform so you can just focus on the microservices that you're building and using and leverage these capabilities to support those apps. Let me end with one last thought, which is these trends of microservices and cloud native as the kind of approach to building applications going forward on the cloud are surrounded by some more fine-grained design considerations or design principles that many people follow in building their apps, right? Whether it's sharding of data, right? Or decomposing data along with a microservice. One of the things that people often don't think about when they start to think about microservices is you need to break apart the data as well. Having 50 microservices that all funnel back to a single database that stores all the state is a coupling that's happening in that database that prevents you from moving fast. So what you want to do is decompose that data so that the data for each service lives along with the life cycle of that service. And that requires things like sharding or caching. You have to start to think about global distribution, right? How do you build these applications in a way that can be globally distributed, where you can do global load balancing, that they're running across multiple data centers so you can get availability. You have to think about things like circuit breaking, right? If you have this network of microservices that have all these dependencies on other services, what happens to the application when one of those dependencies fails? Do you get a cascading failure through the whole app, or can you cut off that failing dependency and replace it with something else? That's the idea of a circuit breaker, that when something bad happens, I can flip the breaker and I can prevent that failure from cascading through other parts of the system. Or A/B testing, right? You have to start to think about how do I actually use data to make decisions about the design of my application or the function of my application. I rolled out some new thing. Is it actually behaving better? Is it performing better? Am I getting more or less errors? So you need some systematic approaches to how you test for that. That's the idea of A/B testing. So many of these other considerations kind of surround the modern view of how we build applications on the cloud. And what we're doing in Bluemix is we're providing that foundation. We're actually using that foundation ourselves to build our services. So we're using ourselves as, to learn, to understand what are the capabilities that we need, and we're providing those services for you to build your applications on top of. So then let me turn it back to Bala and talk about the process part of this.
All right. Sure. Thanks, Jason. So given some of the transformation to microservices, given some of the tools, one of the areas that becomes really important is how do you create a development process that's agile and effective. So we have, as part of the garage, instituted a methodology as well as the core technologies underneath it, like pair programming, et cetera, as well as the tools that Jason went through in terms of not only the Bluemix platform, but also these services to be able to have an effective outcome-based discussion in terms of very rapid build-out and iteration of services. Part of that, and from a hybrid context that becomes really interesting, is release management and deployment management. So when you look at release management, especially when you have a set of existing applications and their APIs, you have new applications that are being built very fast, dependencies between them, because the entire world is not independent data independent microservices, et cetera, or necessarily even stable APIs. You need a release management methodology that kind of spans across these, which is you're able to specify dependencies and gates from API dependencies to component dependencies, some of which might be on some of the newer microservices platforms, Cloud Foundry or Docker, some of which might be based on existing architectures and existing platforms. So release management is an element, and that's part of the capabilities that we bring together as part of cloud. The second element, which is the deployment part, which is having the flexibility to deploy these elements across technologies, Cloud Foundry containers and patterns of existing VMs, and doing it across clouds. How do you get a system in which you can couple some of the release management tasks with the deployment tasks? And deployment is particularly interesting because you might be doing, for example, dev and test on a cloud, maybe even off-premise, and then move that consistently on-premise. So in a hybrid environment, those are some of the interesting challenges. And having the metadata and the representation, not a lift and shift that says, hey, I've dev'd it in the external cloud, now I'm going to have a complex procedure to bring it into production. That's a hard problem. You'll introduce a whole bunch of interesting errors, et cetera, et cetera. So having a consistent, continuous integration or a continuous deployment model to be able to support multiple technologies across multiple providers becomes an important attribute of how you deliver clouds as well. Steve went through this, but this is perhaps one of the key elements of being successful in a cloud world, which is how do you decompose data? It's decomposition of data into microservices, so sharding it in the appropriate way and having APIs as a way to communicate between distinct data sets. The ability to have various other forms of integration, and this could be a day's conversation, but how do you move data? How do you obfuscate certain columns in a table? How do you tokenize data so that you can still do things like analytics without exposing sensitive data, whether it's PCI or HIPAA or whatever? So the set of technologies that let you move data to where the compute is, or vice versa, being able to manipulate and shape the data in various ways, bring data containers, whether it's databases or some of the more the NoSQL platforms, bring them into the context of the application. All of these are critical elements of how data integration plays a role in a hybrid cloud. I can't understate the importance of data, especially when you get into a hybrid environment. It's perhaps one of the data design, data propagation, large bandwidth transfers are perhaps central in the considerations of how we need to be successful in the context of hybrid cloud. After that, maybe you guys should have been downstairs in terms of the data section. But anyway, so just to finish it, and we'll have a few minutes for questions because I think this is much more of a much less formal session. We've brought a lot of these capabilities together into Bluemix. I think when you look at Bluemix, it supports Cloud Foundry as an abstraction on containers. It supports direct access to containers. It supports VMs. As we continue to evolve, we make the entire environment more seamless. We provide a category of services, both business all the way down to some of the microservices enabling capabilities, et cetera, et cetera. And I think we view that as kind of the central point of how we enable in a seamless way, in an open standards-based way across public, dedicated, and local, the ability to support cloud native as well as traditional applications. So I'll pause with that. Any questions? Usually somebody has to break the ice, so it could be a question like, I mean, man, it's a bad day outside or something.
Yeah, go ahead.
The valet key approach is kind of a delegated model. So especially for accessing things like object stores where you want to give someone a temporary key, instead of giving them persistent access to a database, you give them a temporal key that lets them access the database for a particular period of time, and then the key can be revoked, versus giving them an ID that gives them persistent access. So especially for cloud scale and for some of the security and other governance characteristics, a valet key approach is becoming more and more a way to do that, especially for object-oriented databases or object stores for the most part. Any other thoughts? I mean,
no other questions?
Any experiences that you guys want to share? I mean, do Do these models make sense? Yes.
When you talked about the microservices, and one of the downsides is you're going to have literally potentially hundreds of them running across machines, and then really operationally, that's where you shall. And we should really talk about operationally, how do you manage such a diverse set of services?
Yeah. Yeah. Yeah, I'll repeat the question. The question was essentially, I alluded to the fact that with microservices, you make this trade-off between kind of speed of development and operational complexity, but I didn't address well how do you actually deal with the operational complexity. And the reality is, some of that has to be dealt with by the environment you run it in. I mean, part of the challenge of microservices is what is the tools and environment around which, or that you wrap around those microservices. And what you're seeing happen is a number of things. I mean, some of it is, you look at things like visibility, logging, monitoring, alerting. Those tools have to do what we expect them to do now, which is kind of instrument and give me data about what's going on within each of those discrete services. But those visibility services also have to start to understand things like the relationships between the components of your application. So one of the things you're starting to see emerge in the microservices space is tools that automatically give you visibility into who's talking to who, what are the connections between everything, because that becomes much more complex. I mean, play out that 300 microservice app and think about what are all the links that are happening between all those services. So there's a dimension of tools with things like management and monitoring tools that actually have to understand microservices apps. Some of it comes down to you have to manage that complexity through how you actually run the service, right? If you really follow the principles that says, all the instances can be thrown away, that you have things like circuit breakers between them, then you have a platform that's deploying and watching those things. So when failures occur, they're killing bad services and replacing them with new ones. You get an environment that has the ability to kind of heal itself in the sense of kind of taking care of those issues and doing replacements. That wouldn't work in a traditional model where you can't make those assumptions about the components of the application. And so some of it is kind of, I'll say, active management or the architecture of how things run. Some of it is the tools and services we have to wrap around it. And to be completely honest, some of it's still emerging, right? I mean, there are lots of interesting large-scale use cases for microservices, but they all tend to be, many of the kind of highlight ones tend to be a single application or a team that's gone very deep, and they built a lot of the tools themselves. And kind of generalizing this and democratizing it and building general purpose tools around it is something that's kind of emerging now, right? That we have to work through this problem.
Yeah, I also think another dimension of this is consistency, right? So I think one of the things you find that if you're not consistent and you have a variety of small-grained services, you get into management hell, not from managing the application, but from the set of tools that you use to manage these services. So part of what we're looking at, and part of this framework, is to establish a set of consistent elements that help you support these processes. Being able to bring everything into a common stack from a logging perspective. Having similar monitoring functions that can correlate stuff becomes very, very key in terms of being able to successfully do microservices. The other thing, which is, I think many of the principles of management, like ITIL, don't go away. I mean, I still think there are elements of change management, release management, a notion of a CMDB, et cetera. They don't go away. They just manifest, as Jason was mentioning, in a different way. Dependencies are much more dynamic. You can't look at a static system in terms of, hey, here are the dependencies of these. You have to be probably at a higher level, but be able to look at the dependencies depending on the context of the problem. The other thing that we've seen is, and the reason why containers are important, is because what is immutable changes. A server is, in the past, a server was immutable. You put an OS, you have patch management. Sometimes patches work. Different servers drift from each other. I think we're looking at new philosophies like images are immutable, and the only way you ship a patch is an image, right? And so some of these philosophies of management are also changing. And so it's important to complement some of those elements and not treat a container as a server, for example. That kind of defeats the whole manageability perspective. So there are many elements, to your point, that kind of do that.
Yeah, maybe the other point to kind of emphasize, since we have this up, and the reason we brought some of this up in the context of a kind of a platform discussion and the value of a cloud platform solving these problems, is there's relationships between all of these domains. So if you look at, take a simple example. Let's say I have a microservice running in a container. The way that we approach the world says, okay, that all of the kind of data about the execution of that service is flowing through a common messaging fabric into a single common logging and monitoring system. So you have visibility into all of the services that make up your application. That logging and monitoring system can flow that data now for the entire application through something like Spark to do real-time analytics to look for patterns that generate events. Those events can get alerted to a person if a person needs to take care of it, but those same events can flow into an autoscaler that says, hey, there's something wrong here. I need to replace something, grow it, shrink it. And so all of these services are supporting discrete aspects of the application, but they're connected together across the life cycle in a way that's driving that consistency that Bala talked about, that you have a consistent approach to those horizontal problems that make this a more manageable situation to deal with.
I think that leads to the challenge of updating your operational processes, your steady state processes, to actually leverage these new capabilities. And as much as we talk about the technologies and the services, the process evolution is a real big problem.
It's as important.
Absolutely.
And which is why it's kind of critical not to throw the baby away with the bathwater, meaning that I think new approaches, I mean, idle is old stuff, right? Personally, I think the philosophies that are espoused in idle, like change management or release management, are still valid. The tools and the optimization of those processes are completely different. So I think from an enterprise transformation perspective, it's not like throw away everything. It's how can you evolve some of these to take advantage of some of the cloud native architectures and integrate it with existing systems, which is an element of hybrid, because we are going to do hybrid management at the end of the day. And so that's an element that becomes really important.
I think we're out of time. Okay. All right.
All right. Thanks, guys.
Thank you.